Hi everyone, welcome to today's webinar on the mass haul, ground types, and advanced material handling. My name is Erin. I'm one of your resident webinar hosts here at Softree, and today we are going to be spending the next 45 minutes really diving deep on the topic of ground types. To start, I really wanted to kind of begin with a bit of an introduction about why ground types are important. And if you are not using them in your RoadEng projects now, hopefully at the end of today's webinar, you'll start to consider adding them into your models. So ground types are one of those things that are really, really important and have a very large impact on a lot of different elements within our RoadEng model. For example, ground types can impact the volume of material you end up reporting inside your project type. With that, they've got different geotechnical properties that are going to impact that volume, whether it's through their compaction and expansion factors, or whether it's through the slopes. So different materials have different abilities to have different cut and fill slopes. So those are going to have a very large impact within your model. Ground types are going to impact the ability to define what is reusable material that you can include in the construction of your prism, or what material is going to be wasted. So by defining these different ground types, we can figure out what material we can work with. We can also figure out where that material is coming from, where it's being moved to. So accounting for that within the model gives us additional information, helps us figure out how many truckloads of material we're going to need, where it's coming from, where to move it to as we go into the construction part. And then all of these elements regarding ground types really do have a large impact on cost. And the ground types themselves have differing excavation as well as embankment costs associated with them. So all of this together really helps us to understand the importance of including ground types. So today's webinar is going to be, talking a little bit in more depth than we usually do in our webinars about ground types, how to define them within your project, how to work with their different geotechnical properties, in particular the compaction and expansion factors. We're going to talk about tracking material movement and how you can account for these ground materials in that model with looking at both the mass haul as well as Softree's proprietary Opti-haul diagram. And then finally, we're going to go and take a look at terrain subsurfaces. This is where we are not talking about ground types at the center line through depths. We're actually looking at it as a subsurface. So we're going to talk about how to create one of those, and we're going to do that at the really far end of the webinar, actually even after the questions, because that part's a little bit more complicated, but we'll show you how to work with them, how to implement it, and how to reference those in location. So that's our plan for the next 45 minutes. Again, if you're new to our webinars, we encourage you to interact with us throughout the webinar. Type some questions in. We'd be happy to tackle those. And if we don't even get to your questions, sometimes there's too many to tackle live. We always make sure we follow up with all the question askers after the webinar. So that's the plan on a page. Let's just, lean in a little bit further and kind of revisit that reason why ground types and materials matter so much in a project. So I have two 3D views from a project. On the left, ground types have not been assigned. This project was done just using the default ground material only. And on the right, we've got the different ground materials and different stripping assigned to the project. And really, if we go and sort of look at the cross-sectional view as well as the data table of our volumes, you're going to see that there's some differences. There's differences in the slope angles here within the template. From the left, where it's just assumed to be one material, compared to the right, where we're seeing different angles as it hits the different materials. And then in the data table, being able to account for the removal of organics through our stripping, as well as just the impact that those expansion and compaction factors for the different materials are going to have. So again, just to sort of re-echo what I introduced in that initial slide, materials have different factors associated with them, whether that's slopes or whether that's their shrink and swell. And not accounting for these in your RoadEng model can lead to inappropriate slopes, maybe inappropriate materials if you've left stripping within your project, and potentially substantial volume differences. So to work with ground types, the very first step in that process really is making sure that you have your ground types defined in the library within your model. So this is where we just set up what the materials are that are in our project. And you can reuse these from project to project by saving them. So in the ground type editor, we'll define what our ground types are. We'll define those geotechnical properties that I keep talking about, the cut and fill slopes, as well as the expansion factors. We can also define, and this one's done on the cost side here, but we can define a quality factor. We're not going to be covering the concept of quality too much in today's webinar, but perhaps in the future we'll be doing a more detailed webinar that takes that one even a step further. But you can define the quality factor, and then you can also define the cost. So this is our embankment and our excavation costs, as well as the movement costs, and these ones are considered for all the ground types. Once they've been excavated or embanked, how to move them is sort of central to all of them. So we start by creating this definition of our ground types. And then the next step is to assign those ground types to our original ground. And we do this in the assign parameters by range. The same place you would assign a template, for example, a couple tabs over on the subhorizons tab, this is where we're going to define our ground types and what the layers are along our center line. So here you just select them, define the depth, and assign it to our station range. There is another option, and we're going to tackle that one at the end of the webinar, which is talking about subsurfaces. So we can actually bring in all of these ground layers as a subsurface. So the last sort of little piece of introductory concepts I wanted to just introduce before I pass it to Matt here is a couple tabs over. It's on the site prep tab. So this really complements the ground types table. It complements setting up your subhorizons. And this is sort of the site prep and removal of undesirable materials within the footprint of your road prism. And you can see it here sort of highlighted in the yellow. So we can set the removal of organics. And there's a whole bunch of configurations for how you define the area that's being removed, and we'll talk about that in the webinar as well. So let's go into the software. We're going to start talking through some of those concepts, obviously showing you in a little bit more detail how to get there and what to do. So with that, Matt, I'm going to pass it to you for the first time.
Cool. All right, let's share my screen here, and we will go back and forth a few times. So where I'm at with this project, well, I've already chosen my alignment location, or at least largely chosen my alignment location, and it may look decent at a glance, but of course we're focusing on materials today. So right now this design doesn't really account for materials. I've just got my default ground type assigned. So in assign by range, I don't have anything. And I'm not accounting for any of the overburden removal or stripping. So we're gonna just, as we go along here, incrementally add more details, and yeah, we'll see the impact it has, where all that's located in the software, and we'll cover some topics broadly here to start, but some of them we'll expand on here later in a bit more depth. So overburden removal, even if I have a project with just one ground type, I'm probably still going to account for overburden removal if my road is a greenfield project on an undisturbed site. So that being said, usually there's going to be some grass, roots, organics that we want to strip or grub out and remove before we build our road out of this stuff. So if I just look at my cross section here, I'm hatching my fill for my subgrade, I'm hatching my cut for my subgrade, and we can see both of those go right down to that topo surface. Now, if I were to build this, I wouldn't want to use all that material for my fill, I'd want to remove that organic soils layer, dispose of it, and make sure that I'm only building with decent material. So I'm going to do that in assign by range, site prep, and here we're going to assign our overburden removal depth. So I'm going to go 6 inches, so 0.15 meters. And when I do this, I don't want the extent of this overburden removal to be relative to my center line. What I want this to do is to remove the overburden underneath my entire prism. So I'm going to go down here and I'm going to make this relative to my slope stakes. So the outer edge of my cut and the outer edge of my fill. Now I also want to add a little offset here just so it's a little easier to see what's going on. And well, I'm going to apply this globally throughout. So from the start of my road to the end of my road, I want to have that 6-inch stripping depth. And there I'll just mention that we can assign different depths for different station ranges if we like, but I'm not worried about it here. So I'll click Add Edit. I'll hit OK. And just before I hit OK here, we'll notice that right now, before we recalculate this, my mass haul is very close to balanced, but now my mass haul is not balanced, and we can see our volumes changed here too. So my subgrade volumes. If we go back to that cross section that we were talking about, we can see our fill extends down to the stripped surface, which is this little dashed line here, which is good because that's getting stripped, getting removed, and my cut goes up to that. So we're not counting that overburden layer as subgrade. Now down here, we've got our data table showing subgrade cut, subgrade fill. If we want to see how much material we're stripping, we can right-click Data Options, and we'll show that stripping volume as its own item in the list. So there we are. We can see that for this little project here, we're stripping about 650 cubic meters. So that's overburden removal. It's certainly an important part of dealing with ground types, but it's usually somewhat separate from the actual ground types themselves, where we start to get into different surficial materials or bedrocks and what have you. So for that, we're going to start talking about what we're dealing with along this road. And just so on this road, this lower section here, I've got some deep silt. Up here, this is fairly shallow, say 0.5 meter deep, with fractured bedrock below. So I'm going to first make sure that my ground type library has the items that I'd like in it. So this is my ground types table. And I mentioned that we have some fractured rock. So I've got my fractured rock in here, and we can see that has, some geotechnical parameters associated with it, where I'm defining my cut and fill slope by the material I'm dealing with. I've got my expansion factors down here, and we can change this for individual materials if we'd like. Now, I also mentioned that we've got silt. So the superficial material here is a silty material. And out of these defaults, I don't see anything that's going to well represent my silt. So I'm going to make a new material. I'm going to just click New. I'm going to call this SI. We'll hit OK. I'm going to change my cut and fill slopes for this material. So I'm going to go 3:1 for both cut and fill on this. And to start, I'm going to say that my expansion factors are both 1:1, and we'll revisit this after. We'll set our quality, so it's not a very good material. We'll talk about this a little bit later as we get into materials as well. We'll hit OK. And right now, nothing changes in my design. We've added it to the library, but we haven't actually assigned it along the length of our road. So how do we assign those materials? We're going to go back to Assign by Range. We're going to go to the Subhorizons tab. And we are going to click this little button here, and we're going to say for the first, 155 meters of my road, I want to have silt over fractured rock. And again, this is something that we're going to revisit later when we add it in as a surface, but to start, I'm just going to say that this is, 3.5 meters deep. So we'll hit OK. Now, from my start station, and I don't have to know that it starts at 0, I can just leave it at ... but I want that to be assigned up to station 155. So we'll click Add Edit here. Now, from station 155 on, I'm going to say, well, I've got really shallow material there. And we'll say it's still silt over that fractured rock, but I'm going to give it a depth of just 0.5. We'll make sure we hit Add Edit, and then we'll hit OK. And we'll hit OK, and we can see, well, things change. So if you're paying attention in the 3D or the section view, you'll see that my cut and fill slopes go much further. So it changes the footprint of my road. Now, as we change that cross-section geometry as a result of our ground types, we can see that, well, our volumes changed here as well. We still have a deficit. Now, with this, and before I hand it back to Aaron, my cut and fill slopes change in my prism because of a setting in my templates. So this template that we have set, if we expand this, we can see our slopes. We can come in here and we see our cut slope is set to auto. So with that, the template is looking at what material we're going through and filling in that slope based off the material. Now, if we didn't want that, we don't have to have it defined based off the material. We could have this set at a fixed slope, and we can see it's no longer got that hinge point where it's going through the different material. Now, I happen to like where it's following or changing depending on the material we're going through, so we're going to leave that as is for now, and I'll hit cancel, and I'll hand it back to Aaron.
Awesome, thanks, Matt. So our next concept that we're going to kind of introduce, talk through, is one that's hopefully familiar to a lot of you, which is kind of that idea of the mass haul. And we're going to layer in a whole bunch of additional sort of material movement considerations as well. So the mass haul graphic, as you know, gives you sort of that quick qualitative information about what's happening with our cut and fill volumes over the change of our alignment. So this particular graphic is great in giving you that information. However, it doesn't really tell us everything, especially when we're looking at multi-material situations. So there was a theoretical graph, and then here's the actual one from within RoadEng. So we can see the material movement. However, this is sort of considering a single material situation. And as in Matt's example, we're dealing with a multi-material situation, and that's where the Opti-haul, which is sort of a Softtree's proprietary mass haul on steroids, comes in. It gives us more of an optimal movement prescription for the different materials. So I believe in this next section, Matt's going to talk a little bit about the mass haul, the impact that ground types have on it, and then as well introduce a little bit more around the Opti-haul diagram and how you can use it to address the deficiencies of sort of that traditional mass haul. With that, Matt, really short pass back to me. I'm going to send it back to you.
Cool. All right. So mass haul, material movement. Yeah, it's all pretty interconnected. And I guess before we talk about all the gory details, we'll just take a moment to look at the graph and what we have on the go here. So I'm going to right click mass haul options. One, I can see I've got free haul and overhaul showing here. So that's different categories for how far that material is expected to be moved. Now, the graph isn't actually solving for where that material should come from or go to. It is just tracking the surplus or deficit. So at the start here, we can see this mass haul line is dropping, and that's because we're filling more than we're cutting. So we're creating a deficit. We drop below that zero line, and then as we go ahead to somewhere like that, we're cutting more than we're filling, and that line comes back up here. Now, if we're in a deficit, so we've created a situation in our alignment where we don't have enough dirt to deal with this, well, then this cut that we're generating gets moved back. And here, this little green area, since it's less than 25 meters, well, that's our free haul. Now, if we go between 25 and 100, that's going to be our overhaul, and we can see that that's being shaded as another color and represents handling that a different way. Once we get above that zero line, that material is assumed to be moved ahead, and we flip-flop back and forth here depending on how much material we have and what we're dealing with. Now this, when we first started out without my overburden or my ground types assigned, we were very close to balancing. And when I say balance, I mean that mass haul diagram endpoint was very close to the 0 point. But, well, ground types matter, stripping matters, and we can see that we're running a deficit. So if we hover over here, we can see that we are actually going to be, say, 830 cubic meters short of material that we need to build this road. Well, we could deal with that, and I could redesign it. And just so it looks a little nicer, let's do a quick vertical optimization of this so we can get numbers that make sense, and we can do a better job of tracking what goes where. And there we are. So we are much closer to balancing here now. And, well, let's get in a little bit more of the details. So this mass haul is just tracking the surplus and deficits. But, well, where does that Opti-haul come in? Well, right now, we're treating this kind of all as the same. In my assign by range, I've got my fill types. I'm saying just use whatever materials as the top layer for my fill. But in reality, if we're dealing with something like this fill prism is not going to be, well, just silt in this case. It's going to be a mixture of materials. So the Opti-haul actually figures out, well, how much material do I have on hand and how much of that should make up my prism at different locations. So let's just look at this data table again. So last little exercise here, I added in stripping. We can add in more to this data table where we see our volumes Opti-haul, and now we'll look at those cuts and fills as individual materials. And now we can see, well, where's our fractured rock cut and fill versus our solid rock, or sorry, our silt cuts and fills. And it's kind of a devil's in the details side of things. But this mass haul, because it's not accounting for this kind of mixture of materials, it's not as accurate of representation as if we use the mass haul with Opti-haul volumes. And here we can see now we're actually pretty well bang on balancing with our different materials, because, as previously stated, these fills are not just one material. Now, I won't dive into too much of the gory details now, but Aaron introduced a different graphic, and that was the Opti-haul graphic. And this one's not going to look super interesting just because it's pretty straightforward, but it starts to matter a lot more if we have, so there we are. Not super interesting, but this is actually what the software is using when it's solving where that material should come from and go to. But in the slide Aaron had, if we have spots where we need a certain material for a certain type of fill, then we don't get cases that are simple, which are still reasonably well estimated with just the simple mass haul diagram. We end up with different material coming from one location going to another to account for those construction realities. And with that, I'll leave it there. I'll let Darren introduce our next topic.
So our next topic kind of goes back into those geotechnical properties. Matt introduced a little bit around the concept of slopes, showing how the impact that they have by different ground types. And so now we're going to take a look at the other side of the geotechnical properties that we account for, which is the expansion and shrinkage factors. So just as a bit of a primer, obviously there's a few different states of material. And when we talk about geotechnical properties, we're talking about their different states. So there's the banked state, or in situ. There is the loose state, that's kind of in between. And then there's the final state, or placed. And these different materials are going to behave very differently in these states. So the volume of the material could either expand or swell, or it could compact and shrink after it's excavated and reworked. And let's just take a look, because I find this is one of those topics that sometimes is a little bit confusing in software. So let's just take a look at two examples. So in this case, we are reporting in banked cubic meters. So we're going to set the cut to be 1. If you wanted to report in sort of final placed volume, you would set the fill to be 1. But in this case, in this example, most typically, our clients are working in banked cubic meters. So our cut is set to be 1. If the material is swelling or expanding, that means you are going to need less of the cut material in order to place it. So you're going to set the factor to be less than 1. And so here's sort of what that looks like. So the material is expanding. Your fill factor is going to be less than 1. Now, conversely, on the flip side, if your material is shrinking or compacting, you are going to need more of that cut material in order to fill the same space. So your fill is going to be a higher number. It's going to be greater than 1. So expansion and shrinkage and the changing of the volumes in the different states of materials is something that can have a very large impact within the volumes of your project if you don't account for it. So with that, hopefully reasonably well done introduction to the concept, I am going to pass it back to Matt. We'll go through a couple examples of this inside the software.
All right. So I'm going to keep this fairly brief on my end. Yeah, and so usually rock, if it's a solid or fractured mass, when you excavate it, after you excavate it, there's going to be more voids in it and it takes up more space. So yeah, just reiterating exactly what Aaron said, but saying it with the software in front of me. We usually work in banked cubic meters. So related all back to the size things are when it's in place. And if we excavate this fractured rock, because our fill factor is less than 1, we know that it's going to swell. And I like to think of it in terms of, well, if we dug a 1 cubic meter hole in this fractured rock material and took all that excavated material and tried to put it back in the hole, well, we could only fit 90% of it back in the hole because it's gotten bigger. Now, most of this project is that silt material that I had assigned. And, well, silt, yeah, maybe if it's some super compacted material in place, might have a fill factor of 1 or close to it. But if it's a loose, fine grained material, there's a good chance that instead of getting bigger after we excavate it, if we dug that same 1 cubic meter hole and tried to put that excavated material back in, but every time we put it back in, we packed it like we would if it was going to be a road, we might find that we have room for more. So we'll just say, well, we might have room for 20% more. So fill factor 1.2, cut factor, if we're working in banked cubic meters, cut factor is always going to be 1. We'll hit OK. And we haven't changed any of our cut or fill slope angles, haven't changed any of our overburden, but we'll see that this nice balance that we have here is no longer a nice balance, just because, well, it makes sense. That material is actually going to shrink, and we're going to find that we don't have enough of it to build what we'd like to build. So that, from a software standpoint, that is the big reason we want to account for expansion factors, to make sure things balance. If we're in a deficit, to at least know that we're in a deficit, and to be able to account for what direction that material should be going. So that's my explanation. The last thing I'll do here, and I'll quickly undo it here after, but of course, if that was swelling and we said that that's going to get bigger, well, we'll find the opposite, and we end up with too much material. So it's a pretty straightforward concept once you wrap your head around it, but as Aaron said, it is a source for confusion, and it's just because it's one of those things that's hard to visualize. It's not just looking at shapes. So with that, I'll hand it back to Aaron, and she'll introduce our next topic.
Awesome. So this one's our final topic of the webinar. And as a reminder, we're going to be taking a piece of this and actually tackling this I'm breaking it into 2 parts and tackling the second half after questions. So our final topic is all about the sub-horizon depth and subsurfaces. So this is where we're going to show you how to use an independent sort of terrain file that as your depth for your different sub-horizons, as opposed to setting different depths along the center line. We're actually going to bring in a terrain file. So part 1, we're going to show you just how to work with the terrain file and what that process looks like inside the software. Then, as I mentioned, we're going to tackle some of those questions that have been accumulating in the chat. Great questions, by the way, live webinar audience, keep them coming. And then finally, we are going to come back and we'll actually show you how to build that terrain file for your subsurface information. So that's it. That's the plan. You can kind of see here in yellow the attempt to highlight what that subsurface looks like and see how it is actually, unlike when we deal with it along a center line, it is variable in its depth across the cross section. So Matt, coming to you.
Excellent. All right. So so far, and just to look around here and we'll see what we're up against. So far, this sub-horizon that we have set is a fixed offset. It doesn't have to be, but if we want it to be an independent surface, we do need a proper surface for it. So we'll go back a little further than just assigning the terrain. I'll make a terrain file out of a DEM data. So if we had someone else modeling our subsurface conditions and they handed us a raster for that surface, well, we can go into terrain. We'll bring that DEM file in just as we would if it was, well, say, LiDAR data. We're going to model a surface out of it. So here we can see what we're dealing with. I'm going to save as. I'm going to just call it DTR1. And we are going to go up here. We're going to add in a new terrain file as a reference terrain. I've got the DTR1 file. I'll hit OK. And then we're going to go up to assign by range. We're going to expand this here. And instead of having that fixed offset, we're going to say, well, let's use that terrain. And we'll do it the whole way through. This is my depth to rock. And there we are. So we can see, well, up here, we've still got that shallow material, and we've got that transition through here, and away we go. And if we go further up here, we can see, well, this one's a little more pronounced where this old pile is being interpolated through. But yeah, at its basic level, it's just as simple as assigning another surface in your design. Yeah, and with that, I guess I'll pause there. We'll answer some questions and we can do the more nuanced, well, if I don't have a DEM, how can I make that surface?
Awesome. So moving into questions, our very first question that we've got here is how do you set it to strip overburden if you have overburden set as a material type with variable thickness?
All right, it complements this quite well. Now I don't have an overburden layer, but I should be able to explain this pretty straightforward. In my site prep tab, this overburden removal, it actually only goes down as far as your layer 1 depth. So really a max depth from topo if you have multiple layers. So if you did something like what I did with my depth to rock here, and you set that as, say, 10 meters, well, it's only going to go down as far as that rock layer for what's being tracked as stripping. Yeah, so that I think is the answer to that question, but I'm going to use that question as an excuse to talk about another aspect of things. So if you have something a little more irregular, and but you don't have that overburden as its own surface, you can also account for that just by playing with the settings here. So I'm gonna first, let's just go back here. So I won't do anything super complicated, but if I wanted to say the stuff right underneath my prism isn't getting stripped out, great, I'll just leave this as relative to my center line, and we'll set an inside extents on that too. We'll hit OK. And there we can see that we're not just uniformly removing everything. So this is kind of more useful for, say, upgrades to ditching and whatnot, where you're not actually doing anything right underneath your center line. Another aspect of that site prep is if you're dealing with large fills, and if you have a parameter where if you have, say, a fill depth greater than 3 meters, you don't have to strip. You can toggle that on, and you can set that max center line depth so it doesn't strip after that. So yeah, pretty flexible, and yeah, it's a good question. Excellent. And of course, let me know if I didn't answer that, and we can tackle it after this too.
Definitely. Okay, so I see a couple of questions here, all kind of around the same space. So this one's actually about the Opti-haul. Does the Opti-haul consider the stripping material that can't be used as fill?
No, not by default anyway. So that is a a little bit of a nuance. So if we assign just our stripping as a, say, overburden removal, then it's, well, tracked as stripping, and it's kind of tabulated separate. So not included in your subgrade material movement, which is what the Opti-haul and mass haul are looking at. Now, if you didn't want to tackle that as its own thing, you could leverage the functionality around the quality parameters. So in here, we could say that, well, we could add in a different layer that's going to be my organic soils layer. We could say that that has a quality factor of 1. And when we're assigning our fill material, we could say, well, that that fill has to be, so in our fill types, has to be Q1 or better. So we could go down in here and we could say, or sorry, Q2 or better. And then it won't use that stripping as what it's looking at the subgrade. So by default, no, but you can force it to account for the movement and disposal of that material in the Opti-haul if you'd like.
Okay, so our next question, and I might suggest this is our last question, and then we'll transition into that additional part where we're going to create the more detailed terrain subsurface file. This next question is, can I export the information of what material should be moved where and share it with my contractor?
Totally.
So I believe this is Opti-haul. So question asker, if I've got it wrong, please, yeah, type it in the chat. We'll get to it, but yeah, Opti-haul export, Matt.
Perfect. So if you just want to see a table of your different materials and the cut fills, so we can just copy this to clipboard if you want to share it in Excel. If you want that kind of detailed breakdown with distances, we can go in here. So we'll add both of these in here. So I'm going to right click in my Opti-haul graph, copy Opti-haul to clipboard. We'll grab all of it. Where's Excel? I'll just paste this in so we can get a feel for what that stuff is showing. So yeah, we'll scroll down here. And what this is giving us is kind of similar to a mass haul breakdown where we can see our cut fill locations, how far that material is being moved, and how much material is being moved by individual material. So totally can get that out in a tabular format as well. And then up top here, it gives a really detailed breakdown of all sorts of other parameters. If you're using pits, pits where individual materials are coming from and going to. Yeah, it's a pretty thorough breakdown of things. Hopefully that answered your question.
Okay, the couple questions remaining in the chat, we're going to tackle you guys privately after the webinar, and if you have more questions, you can keep them coming. We'll just deal with them afterwards. So now we're going to pivot, and if you have no interest in creating a terrain subsurface, feel free to jump off the webinar. And for those of you who are interested, Matt's going to take us through that process now.
All right. So let's see here. Well, it's super easy if you have if it's already been created and it's just a matter of modeling it, as we did with the DEM. But let's just add some stuff in here so we can talk about this first. And all right, so this is my subsurface, and while I've got parts of this that are offset, I've got other parts that are just an interpolation from one point to another. And if we have something really simple, it's totally simple. It's just a matter of modeling turning points into a surface. So the skill set here is very similar to if we're editing a surface with conventional survey data, where we might add break lines in to get what we'd like. Now, if we had a point up here and a point up here with a depth, well, we probably wouldn't want to just have an interpolation that runs from there to there, because we'd end up with, well, surface data above our actual topo. So for me, I like to use the regular grid function of the software and run with that. So let's pop this in here. And I'm going to create a new terrain file here as well. Now I've got a few lines that I'm going to bring in. We could draw them if we'd like, but it's going to be a little easier for me to just talk about them if we can see them here to start. So I've already drawn in some lines. I've got some notes on what my subsurface conditions are. So within this polygon, I'm going to say that, well, that's 3.5 meters deep. This line up here is the transition to where I've got that shallow rock where I had that 0.5 meter depth assigned. But this pile is a pile of old disposed of material. So my bedrock does not follow the surface through there. So I'm going to leave that as a hole. Now, similarly, between this line and this line, what this site is, it's an old quarry, and the strippings were pushed off to the side, so the rock surface drops down. This is surficial material as well. And then on the back side of things, we have this goes from being really shallow to moderate to quite a bit deeper over here. So let's steal these lines, and we are going to use them. So this one, I'm going to set my depth as 3.5. So I'm going to consider this in terms of depth rather than rock elevation. I guess all of these I should make modeled here to start. So that is my depth of 3.5. This, so I'm going to assign my Z value of 0.5. Now that one's also a Z value of 0.5. We could do a bunch of these at once if we wanted. This one, 1.5 meters deep. And this one is 3 meters deep. And I'm going to make this come up here. We'll go over to there. We'll go over to there. We'll go over to there. We'll go over to here. We're going to join that. And I'm going to make both of these a tin boundary. And I'm going to make this a negative. So we're going to model a surface. And I've got something that's kind of abstract, but we're going to say this is my 10th depth rock. Now from my topo surface, I'm going to come in here. I'm going to hit save as. I'm going to save this as a regular grid. And I'm going to say, well, we're going to take this surface. We're going to subtract that surface that we've just created where we assigned our depth. And we'll set this to be whatever level of detail we'd like. Sure, we'll go with that. We'll hit OK. And it's thinking here, shouldn't take much longer. Oh, I guess it's, yeah, maybe just instead of waiting for that to sort through the million subtractions. I'll just open up what we end up with. Wrong one. Well, actually no need because it's done. So we end up with something that looks like that. We model our surface. And there we are. So we end up with those transitions from the line. The stuff that is a blanket offset because of the depth we have assigned is set. This over here is going right through that surface, and that's getting slowly deeper. So that is, yeah, a quick run through how to create something that looks like that, where we've got those surfaces running independent. And with that, that's the last bit of things.
Awesome. Thank you, Matt. And thank you to our webinar audience for attending. Some great questions. This video will be posted up to YouTube sometime, I'm going to say in the next 24 hours or so, I assume. As well, you should be receiving a certificate. If you're here in the live webinar, you will get a certificate emailed to you. If you do not receive that, feel free to reach out to our webinars email news@softree.com and they can help you out with that. Other than that, have an awesome day, everyone. Hopefully you can, leverage some of this great information about ground types, implement it in your projects. And if you have any questions, please do contact us. Thanks, everyone.